Pilots need incredible skill to get their very best out of these machines, but even a complete novice like me can take the controls. However, a little knowledge of the science of flight is a lot of help, as anyone who dares to take the controls will soon discover.
I don't really know how it's going to be honest with you. I think it'll be exciting, but I think it'll be really scary. Scary but exhilarating.
When you're floating around in a ton of metal, it's reassuring to know a bit of the science that keeps you up there. The theory of flight covers some really important stuff, like how do you get up in the air? What keeps you there? And what happens if the engine breaks down? Useful stuff for passengers to know, but essential for pilots, as two complete beginners are about to find out. Okay.
Marie and Tracy both work in the Royal Berkshire Ambulance Control Room in Wokingham.
Ambulance emergency.
When an emergency call comes in, it's up to them to decide which ambulance to send, and that doesn't always mean one with wheels.
I've actually been up in the air ambulance and thoroughly enjoyed myself in that. Obviously, I had no part to play in flying the thing, but it was just amazing what they can actually do. When we first found out we were going to get the air ambulance, we all had to go up to give us an idea of what it was about. And I was just amazed by the experience, really, how far you could see. In fact, I was so taken with it that when I went back to work, I actually handed in my notice to my boss and said that I was going to be a pilot, and that was it.
So they would slow down.
Well, Tracy hasn't actually given up her day job, but she and Marie do want to find out what it's like to be pilots.
Right, yeah. I'm looking forward to it. Actually sitting in the driver's seat, so to speak, and taking over control, and actually how it works. Well, I am a little bit concerned because Marie is a very fast driver, and I'm concerned that perhaps that's going to transfer to her being a very fast helicopter pilot.
And stop the nose rising. Look, see it's rising? Oh, there it is, yeah? So you can see it was going to rise. Yeah. What should you have done to stop it rising?
Push it forward.
Yeah. Do it. Don't be so shy. Okay, yours with the stick.
Anyone who wants to be a pilot has to study the science of flight, and the first question is always, how does a plane or helicopter stay in the air?
I don't know how they stay up there. I know that they do, and I'm quite relieved that they do, but I don't know a lot about it.
To get into the air, you have to overcome the pull of gravity. To do that, the rotors send a huge amount of air rushing downwards. Believe me, I can feel it. And this creates an equal and opposite force pushing up on the rotors. And so the helicopter goes up. And for pretty obvious reasons, this effect is called lift.
As far as we're concerned, lift is what we produce to get 2.5 tons of helicopter up off the ground and accelerate it into forward flight. The blades are responsible for producing in a helicopter both the lift and the thrust to give it speed.
Basic thing about a helicopter is that it's much more simple than you probably thought. Okay, we just fly by using a wing, and we push our wings around in a circle in a rotary motion, so they're called rotors. And the big secret with a wing is that you've got to keep it moving through the air. If you've ever stuck your hand out of the car window, you'll know exactly what a wing is doing then. If you put it out of the window and it's really flat, then it slides through the air quite easily. And if you increase the angle of your hand, it's harder to push it through the air, but also you feel some lift as well.
That's right.
Rotors are like the wings on an aeroplane, and if you look at the end of a rotor, it's got this streamlined shape called an aerofoil. It's the curvature on this aerofoil that gives a smooth flow of air over the rotor. Whether it's a rotor or a wing, it's the aerofoil that generates the lift. The shape and angle of the aerofoil in flight makes the air flow faster over the top surface than underneath. The faster the air flows, the lower the pressure. And the difference in pressure between the top surface and the bottom means that the aerofoil lifts up.
Because of the conservation of energy, that faster flow has to get the energy from somewhere, and it gets it from pressure. So the pressure goes down to enable the faster flow over the top, and the differential in pressure gives you the lift.